the next topic of our interest will be electrostatic induction, that is charging by induction. Charging by induction, that is this 1.4. Okay, so what do you mean by charging by induction? Charging without touching. Charging without any physical contact. Okay, right, that's what you mean by charging by induction. It is simply called as electrostatic induction. In the introduction part of this lesson, I taught you how a silk cloth is charged or how a glass rod is charged, right? Do you remember, children? Right? See, when you rub your glass rod with the silk cloth, what will happen? The glass rod will become positively charged and the silk cloth will become equally negatively charged. Okay, right? Here, this glass rod became positively charged and the silk cloth became equally negatively charged by rubbing them together. That is, they both had a physical contact with each other, right? So, only by having a physical contact with each other, they were electrified or they were charged, okay? But here, what are we going to do? We are going to charge the objects without even having any physical contact. They will not be touching at all, right? That's what you mean by electrostatic induction or simply charging by induction. Okay, right? So we are going to induce the charges without having any physical contact with each other. So now, first of all, let me tell you simply what is electrostatic induction and then we will go according to the book. Okay, right? So what is done? Consider a metal object like this, right? In the form of in the shape of this. It is being placed over an insulating stand. Okay, this is an insulated stand. So there will not be any electrical contact between this metal object and the earth. Okay, there is only a physical contact. There isn't any electrical contact between the object and the earth. Now what I'm going to do is I'm going to bring a positively charged glass rod. Okay, right? This is a positively charged glass rod towards this metallic object. Right? As this is a metal, you know that there will be number of free electrons, right? There will be many number of free electrons in the metal. So what will happen to those free electrons, children? All those free electrons will start to accumulate along this side. Okay, as this positive rod is being held here, what will happen? This will make all the positive charges, most of the positive charges towards itself, right? It will attract towards itself and those negative charges will start accumulating at this corner. Okay, right? So what will happen to this corner of the metal? There is a deficiency of negative charge, right? As there is a deficiency of negative charge, we can say that this side is becoming positively charged. Okay, there is a deficiency of negative charge, so this side is becoming positively charged. Okay, so this movement of electrons towards the rod will happen until these negative charges start repelling those negative charges. Okay, so what I'm telling you, the movement of the negative charges from this side or from everywhere to this side will stop when these negative charges start repelling those negative charges. Okay, right? Then you can say that this metallic object has achieved equilibrium condition. Okay, right? Now if I remove this rod, okay, right, now I'm removing this plastic rod, that is positively charged plastic rod, glass rod. What will happen? These negative and positive charges will recombine. Okay, they both will recombine. Again this metallic object will be becoming neutralized. Okay, so this is the process of electrostatic induction, right? By bringing an oppositively charged rod towards this metal, I am inducing opposite charges on one side and opposite charges on the other side, right? This process is called as charging by induction. And as soon as I remove this rod, what will happen? They become neutralized. Okay, right? So this is the process of electrostatic induction. Okay, right? So this is temporary electrification. Okay, this process is a temporary electrification, right? Not a permanent electrification, temporary electrification. of the objects. Okay, right? So now let's go how it is given in the book. So in your book, there are two metallic spheres. Okay, right? They are identical in all respect. Here when I draw the diagram, they don't look similar to you people. But remember children, they are similar to each other. Okay, right? They are similar to each other in everything, right? In the material as well as their area, size, everything. And they are placed over an insulating stand like this. Both of them are placed over an insulating stand like this. Okay, right? Now what I'm doing is, they both are in contact with each other. Okay, right? Now what I'm doing is, I'm bringing a positively charged glass rod towards the metal sphere A. Okay, positively charged glass rod towards the metal sphere A, right? Now you know by charging by induction that this glass rod, this positively charged glass rod, will attract negative charges towards its side. Okay, so the negative charges will start accumulating over this side. Okay, see, as A and B are in contact with each other, right, what will happen? From B also negative charges will be attracted towards the rod. Okay, right? So from B also they are being attracted. So what will happen? All the negative charges will start accumulating to this side of A, and because of deficiency of these negative charges, this side of B will become equally positively charged, right? So here how many negative charges I have drawn? 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. Okay, right? So this side will start becoming positively charged, right? Equally positively charged. Okay, right? As they both are in contact with each other, the negative charges of B will also move towards A, to move towards this side of A. Okay, now this process will continue until these negative charges will start repelling further movement of the negative charges, right? So still the more negative charges will be attracted towards this glass rod, but that will stop when these accumulated negative charges repel those negative charges. Okay, right? Then you can say that equilibrium condition is being reached. Okay, equilibrium condition is reached. Okay, right? Now what I'm doing is, I'm just separating these two spheres a little bit. Okay, I'm not taking them moved away from each other, but I'm just moving them a little bit away from each other. Okay, this is your A and this is your B. Okay, right? Still what I am doing, still the positively charged glass rod is held over here. Okay, right? Still it is held over here. Now also what will happen? The negative charges will be attracted towards this side and positive charges will be held here only. Okay, right? Now what I am doing is, in the next step, I am removing this positively charged glass rod. Okay, right? I am removing this positively charged glass rod. So when I remove this positively charged glass rod, what will happen? Now this glass rod is holding these negative charges. Okay, right? Now when I remove this glass rod, what will happen, children? There is nobody to hold these negative charges and positive charges. So what will happen? The negative charges will distribute, the negative charges will distribute equally over the surface of the sphere A, and the positive charges will distribute equally over the surface of the sphere B. Okay, will become this B has become positively charged sphere and A has become negatively charged sphere. Okay, right? So I can now what did I do? I have charged the metal sphere A negatively and charged the metal sphere B positively, right? So this is how I can charge them by induction, right? Without having any physical contact with the glass rod, I have charged the metal spheres A and B, right? Remember children, as they are being separated, what will not happen? These charges will not lose. Okay, right? But if they both are in contact, right, even after taking away the rod, if I keep the two spheres in contact with each other, what will happen? These negative and positive charges will neutralize each other and they will become neutral again, right? As I told you here, as soon as this rod is removed, what will happen? It will get neutralized, no? Similar concept will happen here also. If I still keep the spheres A and B in contact with each other after removing the glass rod, charged glass rod. Okay children, right? So this is the process of charging by induction, right? Remember the small experiments which I have already taught you. That is, say for example, this is a glass rod, okay, right, charged glass rod. When I touch this glass rod with the pith ball, okay, right, this is your pith ball, okay, right, when this is your pith ball, when I touch this pith ball with the help of this charged glass rod, what will happen? Charges, right, even though pith ball is a non-conductor, what will happen? These charges will move and will be transferred. A little bit of positive charges will be transferred to the positive charges. Okay, right? Now if I remove the positive rod, what will happen? This pith ball would have become positively charged. Okay, right? And some positive charge of the glass rod will be reduced. Okay, right? The positive charge of the glass rod will be reduced because it has given some positive charge to the pith ball. Okay, right? But here in this concept, it is not so. The positively charged glass rod is not losing any charge. Okay, right? Without losing any charge, these two objects are being charged by the electrostatic induction process. Okay, right? And this electrostatic induction process is the reason, see, in your lower classes and all, you would have played in your classroom, right? Remember, take a glass scale, right, or else it is nothing but just your scale which you use in your schools, right? See, take a scale and rub it thoroughly on your hair, right? Your hair shouldn't be wet, your hair shouldn't be greasy, right? There mustn't be any oil at all in your hair. When you rub the scale on your hair vigorously and when you bring it near bit pieces of paper, you would have seen, no, the bit papers of paper would have been attracted towards the glass, that is your scale, right? The bit papers would have been attracted towards the scale, right? Why is that has happened, children? Because when you rub this scale on your hair, what will happen? Due to friction, this scale would have become charged. Okay, right? Because of the charges on the scale, it will be inducing, right? Like similarly here, it will be inducing charges on the piece of paper, right? So opposite charge will be induced near the surface which is nearer to the scale, and far away it will be opposite charges, right? Opposite to this charge. Okay, right? So because of the opposite charge of the scale and this side of the paper, what will happen? The pieces of paper will get attracted towards the scale. Okay, right? So this is the reason, right? Electrostatic induction or charging by induction is the reason why a scale which is rubbed vigorously on your hair is attracting bits of paper when you bring it near. Okay, children, right? So this is the process of electrostatic induction or charging by induction. Okay, right? Now, come on, let's see the example 1.1. Okay, example 1.1. So what is the question on example 1.1, children? How can you charge a metal sphere positively without touching it? Okay, right? So they have asked us to charge a metal sphere positively without touching it, that is by electrostatic induction only, right? So what are we going to do? We are going to positively charge a sphere. Okay, positive charge to a sphere. Okay, right? So for that, let me take a metal sphere. This metal sphere is placed over an insulating stand. Okay, this is placed over an insulating stand. Now what I am going to do? I am going to bring a negatively charged rod. Okay, right? This is a negatively charged rod. Okay, right? This negatively charged rod is brought near the metal sphere. Okay, now what will happen? These negative charges will be repelling the negative charges, right? These negative charges will be repelling the negative charges of the sphere. So due to the repulsion of these negative charges, the negative charges of the sphere, right, of the sphere will be repelled away. Okay, so negative charges start accumulating to this side. Okay, now what will happen? On this side of the sphere, there is a deficiency of negative charge, right? So this deficiency of negative charge is nothing but positive charges. Okay, right? Deficiency of negative charge is nothing but positive charges. Okay, children, right? Now what will I do is, I'm going to so this is equally charged. Okay, right? This both sides are equally charged. Okay, now what I'm going to do is, I'm going to ground this side of the sphere. Okay, right? Now I'm going to ground this side of the sphere, right? Now what will happen? These electrons, right? These negative charges will move to the ground, right? Will move to the ground, because you know that Earth is always at zero potential, right? It will be always accepting the charges. So what will happen? These electrons will move towards the ground. Okay, right? So when the electrons are moving towards the ground, what will happen? The positive charges will be remaining, whereas the negative charges have moved towards the ground. Okay, still this negatively charged rod is held here. Okay, now in the next step, what I am doing is, I am removing this negatively charged glass rod. Now what will happen? The positive charges on the sphere, there is nobody to attract those positive charges. So what will happen? These positive charges will get equally distributed all over the sphere, and now I can say that this sphere has become positively charged. Okay, children, right? So this is how we have to charge a sphere positively. Okay, now let's see how can we charge it negatively, right? Negative charged sphere. Okay, right? Same way, if we want to charge a sphere negatively, the same thing will be happening, but this is a metal sphere placed on an insulating stand. Okay, instead of bringing a negatively charged rod, I will be bringing a positively charged rod towards the sphere. Okay, this is a positively charged rod brought near the sphere, right? What will this positive charge do to the electrons of this sphere, children? What will it do? It will attract all the negative charges towards itself. Okay, right? So on this side, negative charges will start to accumulate, and on this side there will be deficiency of negative charge. So this side will become positively charged. Okay, right? Now what will I do? I will ground the sphere on this side. Okay, when I ground the sphere on this side, what will happen? Here in this case, what did happen? Electrons were flowing from the sphere to the ground, and here electrons from the ground will flow towards the positive charge to neutralize all these positive charge, right? Because we know that there is a high, now this side of the metal sphere is at a higher potential and ground is at a lower potential, right? Charges will always flow from higher potential to lower potential. Okay, right? So in order to neutralize all these positive charges, what will happen? The electrons will flow from ground to the earth, to the sphere. Okay, right? Electrons will be flowing towards the sphere, and we are neutralizing all those positive charges. And when I remove this positively charged glass rod, what will happen? The electrons or the negative charges will get equally distributed over the sphere placed on the insulating stand. Okay, so now I can say that this sphere has become negatively charged. Okay, children, right? So see, only difference between charging a sphere positively and negatively is, in the case of a positively charged, you are bringing a negatively charged rod and electrons are moving towards the ground. Okay, right? Now in case when you are charging it negatively, you are bringing a positively charged rod and electrons are flowing from the ground to the positive side of the sphere. Okay, because the positive side of the sphere is at a higher potential, so electrons will move towards the positive charges to neutralize them. Okay, right? So this is how you have to charge without any contact, right? That is charging by induction. Okay, right? So that's all, children, right? This is a simple concept of charging.